I'm Bill Maxwell, as Patrick said. I will be going over how to build next-gen agents with MCP. And so we'll just kind of set some context with what MCP is, how to use it, and how it kind of works. And then we will get into building our own agent that will end up playing chess with us. And we'll be starting with a text-based game and moving our way to a graphical one where you can interact with the agent through a graphical chessboard. So I'm not going to go super in depth on what MCP is. Tomorrow I'm giving another talk on the guts of MCP. But for the purpose of this workshop, we're going to go with MCP servers are essentially like USB-C ports for AI applications. So being able to plug in systems into models and making that easy to consume. They're portable between models and systems. So any of your clients that support MCP will be able to use those tools and have those capabilities. They connect in two primary methods. You've probably seen JSON snippets that have either like a NPX or UVX when running your MCP server. That's typically running at local, and it'll be communicating over standard I/O. And in that case, it's just basically a local process, and your client is passing messages directly to the MCP server. And that was sort of the way it started out and where it originated from. And it's evolved to streamable HTTP. So now you can have centralized hosted MCP servers that your clients can connect to remotely. And they or also as a third party, if you want to provide an MCP server to your customers and users, your systems, you can also build and host and platform or manage it that way. Previously, they attempted to do the remote bits over SSE. You'll still possibly see a few of those around just because all of the indexes get scraped and they're really not going for quality just yet. So you might run across a few of the older SSE-based servers. On a server side, an MCP server, the core thing I think everyone thinks of when they think of MCP servers is tools. And basically that is the actions that the agent and the client are going to be able to take and interact with those systems. And so basically with these, you get records, change a database, query a database, call an API, any of those are pretty common pieces. The other bits are more around some of the UX and the data that might be interacted with. So prompts guide the user on how to interact with that server. Resources are files or URLs to data or records in a database that need to be referenced. And so the server can present those to the client. The reason I bring some of these up is tools and resources are going to be pretty core to what we end up building today. So those are some important concepts. The others that are on the client side are sampling, which is a weird name and they'll admit it. But basically it is the server requesting the client to make an LLM call. So if you've pulled some text, you can ask the LLM, the client, to summarize that text for you, have it go back to the tool, get processed, and sent back. Elicitations are a pretty vital part. Those come back and confirm actions from the user. So the user can either confirm or deny an action, or did you really mean to deposit $1 million? Like confirm that the data and the information is correct. And then roots. I don't really think anyone uses those, but basically they just tell you where in the file system, it tells the server where in the file system they can interact with things. So let's get to the fun part where we actually build and do the code. You will need an OpenAI key. If you go to this URL, you will go to a Word doc or a Google Doc that will have an API key that you can use for this if you don't want to use your own. So yeah, if you visit this, it will take you to this document where you can get the key. I previously tried this with a QR code, and then it ended up on everyone's phone, so I'm hoping just the URL this time. So I put this on the next slide. For those of you who have the key, the next bit is to install Nanobot. So we're going to be using Nanobot for this. It is an open source project by OBOT. It is like a lightweight agent framework that basically is a full MCP client. It implements all of the bits. It allows you to define an agent, which we'll go with as a model, instructions, and tools. The tools will be provided by the MCP server. And we'll be using Nanobot. So we'll go into a little bit more on that. So if you're going to build, you will need Nanobot. Okay. And then last, you will want to clone this repository. And this will have everything we need to set up the agent today. While we wait for everyone. Yep. Yep. Do you need this one or the pre? Okay. Sorry. Yeah, please stop me if I'm going too fast or you have questions, please ask. Happy to. Okay, has everyone been able to install Nanobot and clone the repo? Anyone need help? Okay. Okay, so I'm going to work out of this here for the most part. Going through the repository, if you go into the Chess MCP directory, you'll see there is a workshop and a workshop live folder. You'll want to go into that folder as we work through this, and that'll be the primary. If you get lost or get stuck, the solutions are in the solutions folder, and the README and the slides that I'll be working off of exist in both. I am going to cheat a little bit and just give you, I am going to have the README open in another folder because I don't want to type everything. Okay, so we are going to build a fully functioning Chess MCP server. It will have a backend. It'll have some tools to be able to make a move. It will be able to have the rules enforced, and you'll be able to actually play chess. So it accepts the algebraic notation, which is knight to e4 and that type of thing. I personally am not super well versed in it and have to often ask what I mean from the model and have it tell me. But then this will have state. It will have a way to display the board. And then we're going to take a moment and go over like MCP-UI. And then we will implement the UI elements for this agent And then you can drag and drop and play chess. Yeah. So you will need Node.js. You'll need some basic TypeScript, your editor of choice. I'm going to use VS Code. Command line, you'll need two, one to run the server and one to run the nanobot instance. And we've already cloned. And now, so in the workshop live folder, you're going to want to install our NPM dependencies. What we're going to be installing is we're going to be using MCP-UI server. We're just going to install that now. We're going to use the official SDK from the Model Context Protocol. We're going to use chess.js, which is the backend for the chess engine, and then Express and Zod for types. Okay. Gotta held it myself. All right. So now we're going to create our minimal MCP server. We're going to be adding, we're going to look at the basic structure of the server. We're going to register our first tool. We're going to fire up, we're going to set up the transport layer, and then we are going to have our first tool and test that out with Nanobot. And so our first goal is to create the server TS file, and you will find that in source lib server TS. You should see it empty with that. And like I said, I'm going to cheat and copy this, and I will walk through it. Yeah.
I want to zoom in a little bit when you were showing code.
Oh, yeah. Okay, so in this file, we're going to add our imports. We're going to do add express. We're going to add our middleware. We're going to pull in the MCP server from the SDK, and then we're going to use Zod. So here, can everyone see this? Is this a good size? Good, thank you. We're going to create our new server in this function here. We're basically just giving it a sample name and a version. Yeah. So then, once we've created our server, we're going to register our tool. This one is going to just add numbers. So for this one, we're just going to keep it nice and simple. We're going to define our tool and give it a description and its input schema. This is going to take the left and right operand of an add function. And so here you can see we're using Zod to describe that it's numbers and then give it these descriptions so that the model can view these things. Your tool names and your descriptions, your tool name probably is most important, followed by the description of each of these when building your MCP servers. If you want to have success, you'll want to make sure that those are very descriptive and accurate so that the model doesn't really guess. Then we're going to create the actual body of the tool. And so here, we are going to return content of type text and basically just say the sum of the left and right is the left and right. And we'll close that out and then return the server. Just make sure you can see the whole function. And then we will wire up Express. And so we'll mount it to /MCP, which is the convention of MCP servers that are over streamable HTTP. We'll log, and we will listen on port 3000. Sorry. Okay. Sorry. Was everyone able to get this? If you fall behind, again, the solutions, if you want to look at the files, they are in the steps. So we're on step 1. You can also see it here. I'm going to actually copy out the nanobot YAML because it's currently in the forum for a later version. So you want to edit your nanobot YAML to look more like this for this particular part. And so just kind of breaking down our nanobot YAML file. This is basically, as we were saying earlier, this is our agent. It's really quite simple. It is just a model, some instructions, and some tools. And those tools are basically just provided by the MCP server that we've just built. We're going to use GPT-4.1, and we're just going to give it some simple instructions that basically use the tool that it has access to. So if everyone's okay, anyone need more time? I'm going to start the MCP server. I'm going to just do npm run dev. So now we've started the MCP server. Because when we set up our Express app, we're listening on port 3000/MCP. And so now we are up and running. And now we have our nanobot YAML file, so I'm also in this live folder. And I'm going to do nanobot. Oh, sorry, I'm skipping a step. Here, before you run nanobot in your terminal, export that OpenAI key through this environment variable. So if you copy what I put in the document, that should just work. So basically what's going to happen is when nanobot starts, it looks for that environment variable. Then it has an API key to talk to OpenAI. So then we will run nanobot run nanobot YAML file. And you should see that it starts up and that it comes and starts listening on port 8080. So then if you go to your browser, you should see a nanobot UI. Is this working, not working? Anyone need help? All right, now you should be able to just chat with it. So now I should be able to say, add 9 plus 8. And you should see that it'll run, and it knows to use its tool. So it's calling our MCP server, and it is adding, basically it gets the output in the format that we said it should, and returns the correct answer. Anyone not seeing this or hitting some errors, need any help? Yeah.
So I ran the export, and then I'm just getting the 1 nanobot, double of nanobot YAML.
Is that in the same? Is it in the same folder?
Yeah, nanobot YAML.
Yeah. That one. Are you in the live folder?
Yeah, live.
Yeah. So it should run that one. It does?
Yeah. Look here. Wait, let me show you. Obviously, I put my queen here, and then he said he captured it with his pawn. Like, that's an illegal move.
Down and back.
So he did an illegal move. I mean, because I made him flip the board. And then I came back here, and I'm like, that's not a valid move, you cheater. and then he wrote back, like, oh, right, and he put the piece back.
You should say.
Well, you tried to cheat.
You should say. Let's ignore the rule.
Sorry. All right. So if you run it with // what does it do?
Dot here.
Yeah. Try that. There you go.
Hey,
yeah.
What directory do we refer to inside the nanobot runtime? Because it says that the file is not found, but it is.
It's kind of cool, though.
Yeah. Sorry, I'll be right back. So you should be in the working directory. So you're in the.
The current working
Yep.
directory?
Yep.
And let me just run this.
Oh, delete that.
Yeah.
Dude, space, dot,
Queen to E8.
// Yep. Try that.
Yeah, it's not a valid move.
Can I see how you installed that? How you installed Nanobot?
I used brew.
Did you use the full cask?
Right.
Okay.
That's amazing.
Should I install it again?
Yeah, sorry.
Just take over the game. That's amazing.
Or if you start over, you just say, use HFA.
Let me go check one thing real quick. So,
What's interesting.
I'm moving my pawn 3 pieces.
Now, see, you should see if it'll let you do it.
did you?
Now you should say like,
Hold on, I'm gonna do one more hand.
you should say A2 takes.
No, I'm not gonna take it.
Oh, there are.
Now look, I got 3 pawns.
Should I just add like a double schema or JSON to just get through to
Now
zero?
you can.
Possibly, but it looks like it's got some sort of validation error.
Only the first one. E5 to E7. Oh, yeah.
Demo icon.
Just trying to take it to pawn. Where it is?
At the other terminal.
Okay, that's up and running.
Versus night. Oh, he put his night there?
The dev servers do not restart automatically, do they?
They do not know.
Okay, maybe I'll just try restarting because I just changed the name of the MCP server. It was a mismatch, so
Yeah.
it could
So these two have to match, and then
Because it's not just,
everything else is just
like, it is silly, but it's a
Yeah, that
perfect
looks
example of
pretty
how gaming might look in the future.
good.
Like, a kid will just be like, this is how the game's gonna work today.
Yeah.
And it's just like, on the fly, they'll be able to play games the way they want to.
That's okay, I guess let me just go
Which
through.
will make
Can you
everyone-
copy the nanobot YAML out of step 1 and just copy the file directly there and try that?
You can cheat. I just missed how you started Nanobot.
Oh, it is, you export the OpenAI API key, and in the same terminal it is nanobot run space dot / nanobot YAML, dot YAML. Cool. You are up. Did that help?
No, no. What do we expect in schema?
I don't, I'm guessing it's like a validation thing. It doesn't seem to like, which nanobot YAML file is this?
Is this one? I just copy the content from
I think it's Quinn.
this guy.
Okay. Yeah, and that should be main test, okay. Yeah, this really shouldn't. Can you brew uninstall it?
Sure,
And
let me
then,
try uninstall.
yeah, and then, because there's a version, there's a brew install nanobot, and then that one is broken.
Oh, okay.
So there's one with the, yeah, let me put it back up on the screen for you. So if you're seeing an error when you install Nanobot, if you did brew install Nanobot without putting the Nanobot AI tap, that version is broken. We're still working with upstream to actually get that fixed. So if you could brew uninstall the Nanobot that way and brew install this Nanobot, hopefully that fixes the issue. Okay.
You're supposed to install the tab, right? Tab.
Yeah, you're supposed to install the tab.
Oh, we're supposed to install the tab? Yeah,
Yes.
on the Mac. Oh, okay, that's what I had. Never mind.
Okay.
This is what we get based on that request.
Did you?
We ran the server here.
Yep.
Did npmi,
Yep.
server TS files. We looked at the solutions for step 1, looks the same.
Yep.
The YAML file, I didn't modify because it looked the same.
Sure.
And is there anything else we're supposed to do other than MPI and then run?
Yep, that should be good. And then here you're getting. Oh, you want to start the Nanobot server and hit it on 8080. You're not speaking MCP when you go to it in the URL in the browser.
Okay. What do I need to do here?
Go to 80, port 8080, not 3000. Did you start the Nanobot process?
I don't think so. I think
Okay.
that's the missing part.
Yep, you need to start Nanobot, and then that will listen on that.
And really quickly, I've got the YAML here, and I tried to start Nanobot in live. Is that the right folder to start it in?
Yes, it's in live. Oh, the Nanobot YAML should be out here.
So this one is already there, right?
Yeah, overwrite that one.
I'll write that one with this one. Okay.
And how do you start Nanobot?
And then Nanobot.
Now Nanobot's in live.
Yep, it should be the live folder. So then do nanobot space run dot / dot /
For this one?
dot / nanobot YAML. There you go.
Spaced. Cool. Awesome.
Now you should be on 8080.
Thank you, brother.
And then,
Hey, don't worry. It's like trying to find the Docker file. And,
oh, did you export your OpenAI key in that?
oh, not in this one.
Yeah,
right.
you're gonna need that.
Oh, I didn't do that either.
Okay, you're gonna need that.
Okay, but I can do that without that. Right?
There we go.
Cool. Now you should be able to ask it. Huh. you're running it in a folder above the live, workshop live.
Okay.
You're running one down here.
Okay, no worries. I'll
Yep.
fix that. Thanks.
Okay, so you guys are good. Oops, sorry. Yeah, I will not do that twice. All right. Were you able to? No? Okay, I'm sorry. I will look at this with you.
Not a problem.
Okay, thanks. All right. So I know a few of you have this up and running. So hopefully you've had fun adding numbers. Let's make it do more interesting things. So just to recap though, what we've done though is we have created the MCP server, we added the tool for adding, and basically the middleware layer. The reason we're using the middleware layer helps us run both MCP and standard HTTP over the thing, the same port, and we are getting our responses back. So now let's get into the chess side of things, which is the more fun and interesting bits. And so here, what we'll do is we'll use the chess.js library. We'll implement the chess tools that we'll need for this. And then it handles the validation. And then we will add game state. It will return the formatted game state. So chess.js is is a library that's out there. We've already installed it. It has the complete rules. It's a pretty cool backend. So we'll get ASCII board rendering. It helps validate the moves, apparently not very well. And then it manages the game state for us. So now, let's edit our server. We're going to delete the tool here. And we will add the new tool. So, first we will add our import for chess.js. We'll have the new chess. We still have our same server. That part's still good. We're going to register our new tool called the chess move. It'll take the move as a parameter. And then when we actually go to do the move, we'll create a new chess object. We will do the move, and then we will return the state. Okay. So I'm going to save that. I'm going to kill my MCP server. I'm going to kill Nanobot and bring them back up. So here's my new MCP server. It started back up, and then I will run nanobot. I'll use the same nanobot file that we had from before. And when I reload, start a new chat, I'm just going to say E4. So it now knows to call the chess move, and you can see that it is now returning the response as we told it to in our file. So here, we're still telling it that our response is going to be a text. It's going to have the current board state. This just dumps it in that notation. It gives a list of valid moves, and then it gives the ASCII format of the game state. And you'll note if you do, so if you say E5, it'll make the chess move again. But yeah, you'll notice that it's actually not keeping state, and you get a new board every time in this particular step. Has everyone had a chance to get it to the point where it's now running this first step?
I didn't get the ASCII to show up.
In the
Yeah, nanobot's not showing the ASCII. Type board.
You're running the complete final solution. This version will only have the move tool. Oh,
Yeah, show where it shows it. But it's keeping the board position.
are you running, where are you running your nanobot file from?
I was running it from. I took the one that was there and uncommented. So it's,
Are you in, is your terminal in the live folder?
yes.
No, there's a chess, no, hold on, there's a chess, there's a CP server.
Yeah, it's in the workshop live folder.
Okay. And then is your MCP server running out of,
Yep.
Which will determine
Yeah, I took
whether this move, what's the
this server code from the README
yeah,
for step 2.
okay.
And it seemed to be persistent in board state.
because the thing is chess. If it's not a valid move,
And that was after you made your first chess move? It's probably the model remembering which state.
Installing nanobot, but then somehow this is impossible. Xcode is fine. I can open it.
Do you have the,
I mean, it's up and running. It's right here. I'm downloading simulators, but it's the latest version.
do you have the Xcode CLI tools?
Yeah. Xcode build. And then I did hyphen version, and it's the latest. That's in the App Store.
It's either outdated or was modified. Please update your Xcode or delete it if there are no updates available. Are you on 15?
Yeah.
Seems weird.
I know, right? Everything's like pretty much the latest. Sequoia 15.6.
Yeah. But your Xcode is the 26 one. Why
Yeah,
would
that's the latest in the App Store. I
Yeah.
only double check. It's not like a developer version or anything.
No, no. You would.
It's just kind of like stalled. I'll just have to follow along later.
I'm sorry.
Okay.
Yes, it's weird.
Never seen that before. And I tried restarting a terminal too, the session. It's going to be the
Yeah,
Reboot.
maybe. We'll let you do like a brew update and brew upgrade brew.
For Maxwell?
Not for Xcode, but maybe it's brew trying to use something in its error. I don't know what's actually throwing the error.
Oh, okay.
Yeah,
Okay. I'm pretty sure that basically the board and what the model think are existing are not coinciding. So when it shows the board, it shows the white move, but black can't move because it goes to move, but white needs to go first. At least that's what's happening on mine. Okay, so now let's add state so that we can actually get kind of going back and forth. So I'm going to kill those. All right, so we're going to, we did that. We played a little chess. So each request generates a new game. So basically, there is no state persisted, although the model is smart enough to remember that it got a tool call response and the state of the board. So it's just kind of holding on to that, and it won't let it go. So again, we can now see the board. We're actually able to make the moves. We're calling our tool. The back end is kicking in. And so now what we're going to want to do is actually have state management so we can survive multiple turns. And so here, we're just going to use a simple session state based on the session ID. So every time you connect to the MCP server, you are generating a session ID. We're going to store that, use that to store on the file system the state of the game. And then we will load that before every move for that session. And then we will be able to play and continue. So now we're going to create a new file in our lib directory, store.ts. And so here we're just bringing in write file, read file, and make dir, see if it exists, and the chess game. So we're going to bring in the backend from chess. And we're going to create a save game function. We're going to take the session ID from the MCP server. We're going to take the game from chess and the chess backend. We're going to check if it exists. If it doesn't, we're going to make a games directory with there, and then we're going to write the JSON file with our session ID and stringify the game. So then it's just going to dump it to file. Then we're going to write the flip side, and we're going to do the load game. And so it will also take the session ID. It will then read the games folder for that JSON file. And if it exists, it will return that data as a JSON or as a chess object with the with that data. So now we'll update our server. And so here, instead of creating a new game every time, we'll let game equal await load. So we'll bring in our load game and save game. And then we'll say if move So here, we're checking to see if it's a new move or if there's no game coming back from our load game state. And then we are going to make the move. And then immediately after, we are going to save our game after we make that move. And we are going to continue returning the same content that we've returned before. And now we should see it persist state, and we should be able to make multiple moves. So we will fire up the MCP server, and then we will fire up Nanobot. Start a new chat. Okay, so here, now in theory, I should be able to say E5. Cool. And so now, if you look at our ASCII, or I can say show board, you can see both pieces have moved, and black was actually able to go because it was black's term according to the backend. The nice thing about when you're building these MCP servers is all your business logic can go into the MCP server, and that way you're not really relying on the model and its guardrails to make the right choices or decisions. So here you get a bit more security by embedding your business logic into the tools, into the backend MCP server, and then you're able to actually build reliable systems. Cool. Was everyone able to get their MCP server to save the state? And if we go back and look, we should see that our games are now being stored in our by session in our folder here. And here, why don't we also enhance our Nanobot YAML file. We'll go back to the fancy one. So that will improve. This gives you some nice things here, so I'll go over that. So you can say, let's play a game of chess. I'll go first. Whoever goes first is typically the white color pieces, and it'll be able to actually execute and get going. Oh, no, this one's too fancy. We're going to use step 3s. Sorry about that. So here what we're doing is just adding a little bit of niceness. So we're adding some starter messages. So when you load your agent, typically in a chat window, you're just presented with a chat. And so that's, what do you type? So with starter messages, we're able to give it basically a nice UI button that lets you click and kick off the conversation. And then you'll be able to enhance the UX a bit. So here, when I create a new one, so here now it's got the chess piece logo, and now you've got some starter buttons, so you can say, let's go play, I'll go first. And so then I can say, I'm going to move to E4. And now it automatically knew and picked up and started playing, and so the agent is now actually starting to play back and forth with you. And so if you know chess notation, you can keep playing. I know E4 moves it, and then I think I've memorized now that knight can move to EF3. So that will move, if I look at the board, So here now we're looking at this, and you have a way to actually play chess with an agent and go back and forth. The downside to this at the moment is we're chatting and we have to do everything in text. And in this case, text is not great, right? Like you have to kind of know this notation. I mean, I guess if you already knew it, it wouldn't be so bad, but it's not visual. It's not a really easy way to think through it. It's not super, like, it's just bad UX. And I think, you know, where chat sort of falls down a little bit. So let's bring up MCP-UI. So MCP-UI, this is what's this helps us, we'll be using this to add interactive UI elements to the chess game. And so this will allow us to basically ultimately have a drag and drop way to interact with it. So real quick, not real quick, but so MCP-UI is a project by a team out of Shopify. I don't know if you're aware of this, but every Shopify account has its, or storefront has its own MCP server. And one of the things they wanted to be able to do was be able to still have that interactive chat experience while still being able to shop. So if you go to with the client that supports MCP-UI, if you go to the Shopify MCP stores, like Allbirds or something like that, you can actually get, like, and say you're shopping for shoes, it will, pull up a catalog of shoes. It'll let you click through the carousels. It gives you a way to completely interact with and still kind of have that visual experience that you kind of want when you're buying something like shoes or clothing or any number of things. You kind of want to see it, right? And so that's one of the nice things about having a UI. And so, they wanted to be able to do that. And so from that, you can also add things to cart, and then you have to go and actually complete the cart experience out there. But what is nice about sort of the chat pieces, or what it's bringing, is you can say, I'm shopping for shoes, and you don't have to worry about the navigation of going to a website, entering into a search bar, clicking on, men's shoes, then sneakers, then all these things, right? If you think about half the things that you're doing on a website when you're building it or looking at it, you're basically thinking through the navigation and how do I find something, right? Like that's where you spend most of your time. How do I get my users from A to B? Chat is really nice because it cuts out a lot of that and what you need to do there. And so the MCP-UI guys, they actually saw MCP, they really liked the protocol, and they figured out how to build on top of it and extend, which makes it nice as a protocol. So what they've done is figured out a way to build rich, interactive UI experiences on top of MCP. And so by doing it this way, they've standardized the way of like the client server side things as far as like SDKs and being able to define specific interfaces and how you can communicate back and forth. They've done it in a secure way, so when you render it on the client side, it is sandboxed in an iframe, and so you're able to trust the code to some degree there that's running in there. It's interactive, so you can click within the UI, or you can chat and have it do things in the UI as well. So it can go both ways, which is pretty cool. It's flexible in that it can embed or have raw content, and then it's they're just extending, and so they're doing it in a way that doesn't back anyone or paint anyone into any corners. I believe the OpenAI apps SDK, I think that's the new one they released, is actually a smaller subset of some of the capabilities that you can do with MCP-UI. And so on the server side, excuse me, you're basically, in your MCP server, you're rendering UI resources. These right on top of just regular MCP type resources. And then they're also making use of the spec where a tool call can return an embedded resource. And so as part of its response, you can actually return both the text and these embedded resources. And it's up to the client to figure out what to do. And so it actually gives you a way to degrade gracefully. So if you send both and your client doesn't actually support MCP-UI or the extensions, then it can just render the text and it never knows anything about the UI bits. Or it can prefer the UI, or it can do some combination of both. So they've come up with the URI schema. They're picking the UI and then giving it a component name and then some sort of instance ID. On the client side, there's another SDK to pick up. It will render those UI resources, looking at the URI schema and validating that. And then to communicate between the iframe and the application, it's just making use of the post message API, the standard one. And so you're able to, out of the box, they've got some actions that are predefined. So the intent is, the user wants to do this or add this to a cart. It can notify. It can just submit a prompt on behalf of the user. It can make a direct tool call. And then supporting links out of the iframe into the system. So they've done a pretty good job with this, and so we'll see this in action, but I wanted to give everyone a quick overview of kind of the components that, that we'll be leveraging. Any questions? Cool. So here we will start with adding basic UI elements to this. We're going to just return simple HTML raw. We'll do just the basics of what we would want to see. Our first pass will just be sort of the HTML element. We're not going to do the interactive just yet. We'll add that next. So here we're going to add our UI resource. After importing the bring in the MCP-UI bits. So really here, the piece that we're going to be changing is our return. So we're going to, instead of just returning the text piece of it, we are also going to return the UI element. So here we're going to create a UI resource. Text type. And our content. Stop it. Our content is going to be type raw HTML, and the HTML is going to be We're just going to dump the ASCII into a pre-formatted HTML text block. And then we're going to do UI metadata. And we're going to say that we want to prefer an iframe size. So yeah, here we're creating our resource. We've added the new type. We're going to give it the URI that it is a board. We're going to encode it in text. We're just going to dump the ASCII straight out to a pre-formatted block. And then here in this UI metadata, we're telling the client library that's going to render this that we would prefer the iframe to be 700 by 700 pixels. So we'll fire that back up. Fire back up our nanobot server. Start a new thread. And now I'm going to move E4. So now it'll actually render this pre-formatted ASCII board game every time. And so here, if we inspect, you'll see that we're in the pre-tags and that the client has done the iframe for us. And so it is drawing and rendering this for us, and the client is picking this. Not every client supports these UI extensions, but the ones that do, you can take advantage of this. Was everyone able to get the pre-formatted HTML? Cool. So yeah, again, the key thing here is that we are returning both types, the text and the UI element. And so it's up to the client to decide what to display. And it still gives us portability. Our MCP server would still work with a client that does not support the UI bits because it would just degrade and use the text bits. But now we can move on to the fun side with the chessboard and actually be able to drag and drop the chess pieces and build that. So here we're going to pull in a library that gives you a graphical chessboard, and we will then be able to move the pieces around and then be able to, yeah, and we're going to be using chessboard.js for this visualization. So we will now create a new function in our MCP server. So this will get the game UI, so I'm going to copy it because it's a bit lengthy. But I will walk through it. So here what we're doing is, again, we created a function that'll generate the create UI resource bit for us. And so here we're doing another preferred, we're setting our metadata, we're giving it a UI element. And this time we're going to go with a 500 by 500. We are encoding it as text, and we're sticking with the raw HTML. If you wanted to get more fancy, you could put a templating system in your MCP server, read render templates, and put that back out as raw text or as raw HTML if you want. So you get the ability to build really complex applications with MCP servers. And so here we're bringing in some style sheets that basically just kind of make it pretty. We have the chessboard, and we're calling the piece themes and just rendering this board element and then putting it into the body. So now we'll update our return content bit. So instead of returning it all here, we will just return, we'll call the method and return that element as well. So we're still doing the same thing we were previously, which is that we are returning the text and a graphical element. And so now we reload our MCP server and we fire up Nanobot. I say E4. I now get an actual chessboard, and now this is much, much better. Because now I can tell it to go ahead and move. That's less fun. So here, you're able to make these moves, and then I can say, go back and forth. And you're able to start interacting with, and now you're actually playing chess with the model. Oops. It's not very good with error correction, or if you make an error to fix it. But here, the key thing is now this is a much better way, more fun way to interact and play chess with your agents than it is to type the notation each time. And so if you want to see, was everyone able to see their chessboard? Cool. So, yeah. So we're still calling the tool, active tool, the chess move tool that we built earlier. The UI is making use of the handler, which handles the drag and drop messages, which then posts the message back to the Nanobot window, letting it know that it should invoke the chess move tool. And then the UI updates the board. And so now you basically have a fully functioning way to play chess. If you wanted to enhance this, you can add additional tools which would get valid moves or undo a move, which would be nice to have. Get the history of the game, analyze its positions.
So much, we're roughly an hour in, so maybe if you do like 5 minutes of questions, then you continue, so break a little bit.
Okay.
Would that work?
I mean, yeah.
Whenever that works.
I mean, we're pretty, actually, we're farther ahead than I thought we would be with the last one.
Yeah, okay, cool.
Yeah, but any questions about what we've been doing or what we can use here? We used basically a file-based storage. You could enhance this. You could use a database and actually store this. You can add auth to it and then actually host this and then have a way to actually play chess against agents and have people connect to it. You can have better UI elements, so you could show all the pieces that were taken off the board or anything that wasn't basically any potential next moves. You can just continue to enhance and show different things. So yeah, if you'd like, the root of this outside of the workshop directory is the complete implementation. You can see that that one has everything implemented and is pretty cool. So we can run nanobot. So here, now let's play a game of chess. And now it has all of the tools, so this is a bit more full-featured in what you would expect. So here, if I move the pieces, the agent knows to automatically move again. The board updates and refreshes. Here we can see that as you're moving, it's going back and forth and able to play. I've yet to actually beat GPT 4.1, but hopefully someone can. I guess it cheats, but yeah. So we actually went by pretty quick. I'm going to be here for the rest of this time, and I'm happy to help anyone or troubleshoot any issues. I know we ran into a few. I did want to say thank you for staying, and if you would like to have a chance at winning a $100 Visa gift card, please feel free to enter. You can come by our booth tomorrow to claim the prize, and we will also be raffling off a Nintendo Switch 2, which you can enter at the table tomorrow. But yes, if you do have any questions or if there's anything I can help with trying to get through, I know there were a few issues, but happy to walk through those with you.
Thank you, Bill. Thanks for spreading your wisdom on MCP, MCP-UI, about so many stuff for people to try and play with. So I hope you enjoyed the session. Like you said, he'll talk more tomorrow, and at the booth you can find them. Do give speakers feedback, right? This is important for us and the speakers, as we know whether you liked it or not and what they can improve. It's always hard to get feedback, right, Bill?
It is.
Yeah. So, and I think you're off now for a break a little bit faster than expected, so you can get probably some food or wander around the campus. And yeah, I think that's it from me. So don't forget the survey, and we're going to start again for the last workshop. I hope you enjoyed it as much as this one. Thank you very much, Bill.
Thank you, Andrew.